So let's start with the XOR model. Like we are going to create the XOR neural network. When we are creating the XOR basic structure, how it looks like. First, we are going to create this truth table for this. So what's the truth table for the XOR? Suppose I'm having X as the first parameter, Y as the second parameter, and G as the output. So I'm having this as truth table. So the basic truth table for XOR says unlike input high. So I'll be treating 0 1. If it is 0 0, then I'll take 0, right? If it is 0 1, so the output would be 1. If it is 1 0, then output would be 1. If it is 1 1, both inputs high, then output would be 0. Which means whenever we are getting same input, the output will be off. When we are obtaining different outputs or unlike output, we are getting high inputs, right? So this is our agenda of today's session, that how to solve this XOR network for our using our neural network, right? So for the neural network, we are going to create this value. Like suppose we have this circle. So in this circle, we have first neural network, right? Then we are going to pass the first part of my inputs, right? Then the second letter, which will be the hidden part, and then finally we will get the output layer, right? So we can connect these outputs from the different layers, and then we can connect these lines from the different notations also, right? Here you can see they are connected with each other, right? Here you can see they are producing output, right? So how you will conduct this output part? So we are going to take this X and Y respectively from these two inputs, and finally my G will be the output, right? And we will see the respective coding part for this, right? So how this XOR truth table is just solved using our network, right? So for this, I'm going to import libraries first. So with the basic library, we are going to import numpy as np. This is the first library we are going to deal with. Second library we will take from TensorFlow, and this TensorFlow.keras models, right? And I'm going to import this sequential part, and this is just module which we are going to import from this models, right? And the second part we are having tensor, copy this line, same again, TensorFlow, and from the keras itself I'm going to import the layers, and this layer will take my dense part, right? So what is sequential? Every neural network, every neurons, every connection is sequentially calculated here. The agenda of this neural network is sequentially being calculated, and we are treating and we are processing non-concurrent values here, right? This is the reason we are taking sequential part. When we talk about dense, means every neurons is having connection with the next layer neurons. Like there is no connection lapse or skipping part when we are having this value, right? So with this neural network, we are trying to solve the respective inputs and the outputs as per my truth table, right? So these are dense, and then we are taking the third library. From this library, I am going to take optimizers, and these optimizers are SGD, and we'll discuss what this SGD is, right? That's it. Now, once they are imported, while they are importing, we are creating the truth table. So how we will create the truth table? We are creating just np.array, and this array will take first input and the two-dimension values. So why two-dimension values? Because we have 0, 0, then we have the second value 0, 1, and then we have third input as 1, 0, and then you have fourth input, fourth record as 1, 1. From this chart itself, you can see this feature term are just being calculated. This part is just being passed to my data set, right? This is the feature part. We are just dealing with this inputs only. Then once the data has been inputted, created, then we are going to create labels. So what are these labels? These are outputs. These are target values, respective target value, and within the target value we are creating 0, 1, 1, 0, which is the respective output of these things. First 0, 0 output will be 0, 0, 1, 1, 1, 1, and you can verify from this sheet itself. This is the target column. 0, 1, 1, 0. Combination is same. Now, once we have created these two things, when we are taking the data itself, when we are trying to print this data, we have array of two dimension, then we have labels. So we are good to process for these values, right? Then we are going to create sequential neural network, right? In order to create this one, we have model is equal to sequential, and this is kind of method, right? So along with this method, we are going to create this hidden layer. If you are going to create this model itself, so you have certain values there, right? You can see this Keras engine, and then sequential and sequential part, right? So how you will deal with the Keras part, how you can go for the complexity of this Keras. So we have keras.io official website. This is kind of API documents where we are taking examples, where we are taking the help of all the modules, deep learning models, right? Creating neural networks, machine learning, TensorFlow, all. So TensorFlow and Keras are working together. So what is relationship between TensorFlow? Here you can see Keras is central part of tightly coupled TensorFlow ecosystem, right? Where we deal with machine learning, data management, and so many other things, right? If you want to go for the API documents, how many layers activation, model training and loss, how you can create the models, convolutional layer, pooling layer, and so on. So we have this part, and every layer weights is just giving this example there and their respective description part. If you want to illustrate more about, you can go for this official website. So let's go back our code. Here we have model we have already created, and you can see from Keras official website we have taken engine and then sequential part. Next objective of our session is to create hidden layer with two neurons, right? For this, what I'll do for my model itself, I'm going to add this value, and within the dense layer I'm going to create this 2, right? What is 2? 2 is kind of like what kind of units, right? What kind of inputs I am going to create, right? So for this input dimension is equal to 2, right? So I'm having 2 input dimensions, so I'll give input dimension is equal to 2. Then I'm having activation. What kind of activation I am choosing? I am choosing sigmoid because it's a binary condition, right? So for binary classification, we choose this sigmoid function, right? Then for the output layer, we have the second layer model dot add. We are going to add one more layer. This layer is also dense, and for this dense layer, we have only one output, and then activation function is again sigmoid, right? So this will be output there. Here you can see in this structure we have one output, we have two inputs, right? So in order to create that weights or tune that hyperparameters, we are creating these layers, right?
Uh,
Yes,
what is the first value in the?
activation function, right? We have already discussed two types of activation function, although there are so many activation functions. So one we have discussed is ReLU. So what is ReLU? ReLU is rectified linear unit, right? So it converts everything with this function maximum of 0 comma L. So if you pass any pixel value or any calculated value at any node, if it will find anything like maximum of 0 comma minus 13, so it will give 0. So it will convert everything. If you look at the graph of this value, suppose here we have this one, and then we have the upward direction, so it will create like this one. The graph of value will be this one, this and this, right? So every positive value will be there, but for negative value, if we have x here, we have y here, so for negative value this graph will be 0. So it will convert every value into the negative. So as far as sigmoid is concerned, it works in a different way. It is having formula for every value 1 upon 1 plus e raised to the power minus x. So what is the meaning of this function? When you are choosing any number, let's say 1 upon 1 plus e raised to the power minus 19. Let's say we get 19 at any node, right? The x value is 19, calculated value is 19. Now go back to the Google, you can find the value of this one. So here you can see, so e raised to power minus 19 is near about 1. Can you see this value? It converted the entire 19 value almost equivalent to 1, right? This is the beauty of this function, sigmoid function. When you go for the another example, let's see, I'm having 1 upon 1 plus e raised to the power minus or plus 22. Let's say I get minus 22. So minus minus cancellation will be plus, and plus 22 will be calculated. So let me keep 22 in this formula. So e raised to the power 22 will be calculated. Here you can see it's a 0.0010 times O. It's a 10 raised to the power minus 10. So 0.0010 times 0 and then 2789, which means this expression is having value almost equivalent to 0. In either words, in sigmoid function, you are supposed to convert any number in this world, any number, 10 towards 1 either or 10 towards 0. This is the job of this function, right? So here we have, let's say 220, right? Can you see the value? It's again 10 towards 0. Let me keep minus 220. So we are getting 1, exactly 1. So this is, you can think about this idea, like how they have developed this function, which is converting any whole number, any integer value, 10 towards 1, either 1 or 0. So this operator is having either output 0 or 1. Did you get this point?
Yeah,
Can get any value that's near about, let's say, 138. So it's not your output. Your output is 10 towards either 0 or 1. Or you can say, if I am getting 0, I'll take it this image is belonging to male image, right? For one output, you can say, you can state that this image is belonging to female. In the and the terms, you can see, you can say this statement. So this is the literal meaning of this 0 and 1 binary classification. In case of cat and dog classification, you are doing the same operation, but our objective is how to convert this drastic value, this very large 138 value, to the form of either 0 or 1. And we know once we get 0 or 1, we can convert either cat and dog, right? Either it will rain or it will not rain, right? We can convert into the binary definition. But what's the intermediate steps where you are getting very large integer values? Once you have done all the calculation in neural network, at the final output you are getting, let's say you are getting 139. What you will do for this 239? This g value, this z output is consisting of 239. So what you'll do, you will just put in this value 239, and you will convert this 10 towards 1. You can see directly you are getting 1, right? So this is your point of discussion, like why we are using sigmoid. So Python is again very abstract. It doesn't say anything. It doesn't describe anything in detail. It just gives the sigmoid and done, right? Even so many people are using this activation and sigmoid, and they do not know the math behind this functionality, right? How they are converting this entire value towards 0 or 1. Are you getting this point?
yeah, got it, got it.
Right? So anywhere, if you see, not in the deep learning, in machine learning, in computer vision projects, in like, suppose let's say I'm going for like computer vision code or code in Python, right? So if I'm going to check this real Python, any website, random website, I'm going to check that one. So if you scroll down, like fingerprint image for non-linear duplication, right? Let's say if we are having this point. If you go down for the layers, so you will find they are also using somewhere sigmoid function. Means in other terms, they will be using. To left. Find some objective where we have computer vision function. Let's say sigmoid function. We are using this one. Right? Here we have the basic formula. Right? You can see this formula, and they are using this as a output for my neural network. But you know the basic fundamental of this term where we are using this output term. Right? Now we are going to, our next step is to compile this neural network which we have just created, this entire model, right? We have created the first dense layer, then we have created the we have created the first hidden layer, then we have created the output layer. It's not the hidden layer, but it's the output layer, and then finally we are going to compile the model. So what's SGD? SGD is going to take SGD. Inside is this SGD. I'm going to learning rate is equal to 4.1, right? And we run this part, we have created this SGD, and then we having model dot, we are going to compile this model for with the loss is equal to mean square error, right? With this mean square error, we are going to take help of optimizer, which is SGD here, right? Which we have just created here, and I'll explain what is this mean square error and optimizer there and everything, right? And then we are going to I'll explain, give me few minutes, I'll explain all these terms like what is loss, what is SGD, what is optimizer, right? Suppose we are going to train, so for this we are going to take epochs is equal to 10,000, and within the epochs 10,000 we are going to fit this model with the data, which is our feature value, and then we have labels, and then we have epochs, and then we have verbose is equal to 0, right? So then we are going to fit this model. Okay, so I think there is some. So now we have data at the first part, and the second part we have labels there, right? So labels is just given over here, that's the output or target column, you can say in terms of machine learning language, right? Then we have epochs, so we have given 10,000 epochs, and we have verbose, right? So let me explain everything. Suppose, what do you call it? Suppose we have training data set, right? So training data set, we have training data set, we have 10,000, right? So within the 10,000, we are not going to give input this 10,000 pixels, right? Any image is having 10,000 pixels, right? So we have seen that any image we have x cross y, and this entire image will be converted into the flattened layer, and this flattened layer will be 1 2 3 1 2 3 4 5 6 7 and then 8. So 1 2 3 4 5 6 7 8 9. So 9 inputs, 9 pixel values, 9 binary numbers or integer numbers are converted into flattened layers. Flattened layer. So these flattened layers are neurons for my inputs, right? Then these inputs are called training dataset, and let's say instead of 9 dataset we have 10,000 pixels for certain image. Now we do not give 10,000 pixels at single epochs or single time. What we do with this 10,000 images, we are giving in batch. So we call this batch, this is called batch size, right? Suppose you have batch size is equal to 50, right? At single round, at single term, you just train 50 pixels at single epochs, right? Single iterations, right? And when then we are going taking the second batch, 50 second pixels, then 50 second pixels, then 50 second pixels, this one. My question is, how many iteration required, right? So what you'll do, you will divide 10,000 divide by 50, because in single iteration we will take only 50 pixels and we train the model. Then next iteration we train the model, 100 pixels train, then we take the next 50 pixels, we train the model. Now 150 pixels train, Then we take next 50 pixels. We are memorizing the features. Model is taking the drastic features, broad categories of the dimensions. Then it has been trained 200. Then next 50, now 250. Then next 50, now 300 train. In this way, how many iterations required? So let's take 200 iterations required. Is it justified? Did I justify my statement? So whenever you are saying like in one epoch, so this entire process is called, this one is called single epoch, right? This is single epoch. Did you get this point? Why we are dealing with this epoch? So epoch is different from iteration. Training dataset is different from batch size, and this iteration, epochs, training, everything is different calculation for your deep learning. Did you in other terms, like suppose मेरे पास एक बड़ा सा pond है, right? I'm having big pond over here. So big, in this big pond, I'll have to carry this entire water. It's a big pool, right? So ये pool में water filled है, right? तो ये water को मुझे pick करके लेके जाना है कहीं दूसरी जगह पे, राइट? तो मैं क्या करूंगा इसको सी वी, राइट? तो मैं क्या करूंगा इसको यहां से जैसे ये वाटर को पिक करके दूसरी जगह लेके जाना. तो you cannot carry the whole water at single iteration, single term. So what you'll do, you just pick 4 liter of water, or you have a small bucket there, right? So within this bucket, you just carry the water into the next pond, right? And you just go to the filter that point. You are supposed to filter this water, right? You have just filter, and you just transfer this small water to this pond. In the next point, you just transfer the entire water to this point in the next iteration, and then we transfer the entire water, and the transfer the entire water, and the when you have filled this entire pool and entire water is transferred to this second pond, this is called single epoch, right? But your water is not still filtered. It has again some impurities here. So what you'll do, you will perform the same operation there. You will carry this water back to the original pond using the same filter point, same bucket. So you will perform the same iteration because water is same, right? Almost same. So you will perform the same. So in the previous session, you have taken 200 iterations. So again, you will take 200 iterations. Now, if you are saying we are having 10,000 epochs, which means you are performing the same operation 10,000 times. Are you getting my points? You are giving that optimal solution, that best solution कि मेरा पानी अगर मैं 10,000 times इस पूरे पानी को filter कर दूंगा, then I'll get the most pure water, drinkable water. तब ये पानी drink करने के eligible होगा. Did you get this point? This is the phenomena, or this is the exact mathematical behind this epochs, iterations, and there, right? So once we have fit this model, and then finally we can print the output of this model. Then we have the statement training completed. Then we can print, use the for I in range. Within this range, I'm going to check for my entire data. It will run till the length of the data is filled. Then for my input data, it will be data and then I. First data will be passed there, and then it will reshape my entire data into 1 into 2, right? One row, two column, right? And then I'll try to predict this predicted label within the model dot predict, and within the model dot predict I'll try input underscore data, which we have described here, and then it will take 0 and then 0 here, and then round, right? It will round my entire probability. It will give the output as a probability, right? Then we can print the output here. So here we have print the input, and then within the input having this data, this first data, and along with the predicted output, right? Let me remove this term here. This would be output, then colon, and then this one, and then predicted label, right? Predicted label here, and then close this one, right? Let me get this code. So here you can see the training data complete. Input is 0 0, the output is 0. The training first second input we have 0 1, predicted output is 1. That's correct as per our trust table we have created at the initial level here. And then we have input 1 0, output is 1.0, that's also 1, right? Then we have 1 1, predicted output is 1, so that's the last column here. Oh, that's wrong. Okay, so that's wrong means we have something something different, right? So what's the accuracy of our model, right? So let me check model dot accuracy. Let me check whether it will give the output or not. Okay, it's not the same code. So let me check what's the code for the same are being calculated. It's having two inputs. The formula for this one, two input, like from where two inputs plus one. Why plus one? Because we have one bias everywhere, right? So for the two inputs from the previous node and multiply by the outputs, right? We have two outputs there, right? So 2 plus 1, that is 3, multiply 2, here we have 6, right? So at this layer, dense layer, we have 6 output, right? So what's here? We have 3, we have 3, 1 plus 1 into 3, right? So we have 1 into 3, like 3 outputs. So it's not 3 outputs, it would be 3 somewhere. I'm going to calculate wrongly. Okay, so thank you for joining. Any doubt, you can write in the chat box.